Hello, everyone, and welcome to the 16. I apologize for starting today's stream a little bit late. I was caught up with a lot of things. And so let's quickly take a look at what we'll be doing for today. Today, we will look at code modularization, quite a big word, maybe, and so whatever it is. And then we will take a look at installing and using third-party libraries. We introduce ourselves to some of the libraries that come with Python, like CSV, like the OS. I think we looked at another one also. Not into so much details, but we use the time also. So, yes, but Python has a community, like a full community where people have written libraries and code that we can just import and use. So we take a look at how to install them and use them. So what is code modularization? It involves the breaking down of a program into smaller self-contained modules or components, each responsible for specific tasks or functionality. Maybe the English is too much or it doesn't even really give you so much understanding. But what it means here is that when we say a module, this word, a module, is just referring to a Python file that contains some logic. So all the files that we have been writing, code in so far, you can term them as modules. So if we say modularization, think of it, you have a big project. So you don't want to put all your functionalities in one file. Usually, if you do that, it becomes difficult when you want to maintain the code and all that. So modularization helps us to break the code down into self-contained modules and, sorry about that, and components. So each of them are responsible for a specific task. So think of it like if you are building an app for, let's say if you are building an app that will contain authentication, that will contain some calculations or analysis. Maybe you have to do visualization in the app. You may want to separate the logics of the authentication, computation, and visualization into different files or modules, more technically, so that if you will have an error in the visualization, you know exactly where to go and look and fix it. Usually, such code bases are hundreds of thousands of lines of code. So if you break them down to components, it really helps you. I told you before that last year my team and I published the software. So when we finished the compiling and everything, I think it was around 25,000 lines of code. So you can just imagine having all of them in one file is not the best option. And so it improves code readability, maintainability, like I've said, and then like it enhances collaboration also. So if multiple people are working on the same project, each of them can be writing for algorithms separately but together, and then it will not be causing any problems. So let's get into Python and see how this modularization thing even works. I'm sorry if the screen went dark. I'm sorry about that. Okay. So in order to learn the modularization, oh, sorry, I forgot to change the overlay. A minute, it's still saying day 15. That is very, very bad. Forgive me. Okay, so now we are all set. So in order to learn the modularization, what we will do is that we will build a simple to-do app. We will not build a user interface app. It's a simple graphical, like the command line. We'll be using that, taking inputs and displaying things in the terminal. But to be a to-do app, I don't know whether we should write the input to a file like a CSV or a TXT, but let's see how that one goes. So if I come into my day 16, You see that I have only one file, the day16.py. Okay. What I'll do is I'll rename it. So I right click on it, go to refactor, and then choose rename. I want to rename it to main.py. No special reason here, so that it will just, that's how I usually do my stuff. And then apart from the main.py, I'll create two or other files. So a new Python file, which I'll call CRUD or CRUD functions. In database language, if I say, others say CRUD, others say CRUD, but if I type CRUD, this is an acronym or an abbreviation for create, read, update, and delete. So if you are building a function that kind of connects to databases, create, read, update, and then delete. So this is where all the functions for creating, reading, updating, and deleting will be. And then we may have another one for input, output. So I just want to create them in advance so that I don't have to be coming to this place again. Input, output, functions. Okay, maybe the three for now. If there's a need to create any other, we will do that. Okay, so I'll close the two for now, and then we'll try writing everything inside the main.py rather. Okay, so what will our database be doing? What it will be doing is that it will take input from the user, store that input inside a file. Should we use a file or not? Maybe we'll be using a dictionary rather. We just make things simple, not so much complex stuff. So it's to store it inside a dictionary. And then when we call for it, it should also give us whatever is in the dictionary for us to read. Okay, so we'll be taking input, we'll be displaying output, and then we'll be able to create, read, updates, and then delete stuff also from our database or something like that. It's not a database, but that's what we're doing. Okay, so the banner, creating a to-do app. First, we'll break down everything into functions. So define take to-do from user. And then this one will not really have an input. I don't think so for now. So we will now say that maybe to do, let's set that one to be equal to input, and then what would you like to do? So we'll take this from the user and then we will return it. We have to return it before we can use it anywhere. So return to do. Okay, so our input function is complete. We can call it somewhere here. If we say take from to do, and then we run our code. So an app. It worked because exit code is 0. There's nothing wrong with our code. So still on the input output functions, let's now define an output that says read to do, or maybe display all to do. So display all to do's. And then this one will not take any parameter for now. And here, let's create a dictionary called to do's that will store our to do's for now. And then now we can say all to do's equal to do's dot items. Sorry, items. Okay. And then now we can say for to do in all to do's, not all to do's. Intelligence is not really helping me today. We can, for now, let's just choose to print the particular to do. Okay, so this function has no return. We don't actually need that one. Maybe we want to also get a to do with a specific ID. So what we can do is define get to do singular, and then we pass in to do. The name may not really be unique. Okay, okay. Let's just use that one so that in case there are more than one, we return all of them. So I don't like this logic that is giving me. So to do keys, what I'm doing here is getting all the keys from the to do dictionary. So if we use the key to do the search, anything that has that particular key, just get it and then bring it to us. So we can say found to do is equal to do's, and then we can pass in the to do name, no, to do key. This will return a single. Okay. There should be a check here. So if to do name in to do's or to do dot keys, to do keys, then this is what we want to do. Return found to do. Else, we can print there is no to do with that name. I hope this function too is not confusing. It shouldn't be at all. This function is what will get us a single to do. So first, it will get us all the keys inside this our to do dictionary here, which is our database. And then if the to do name that has been provided in the function call is in those is part of those keys, then we return that to do. We get everything from that to do, then return it. Or other than that, we will just print that there's no to do with that name. So let's just assume that these are all our outputs, inputs, functionalities. So I can give a comment here if I want to make the code nice. So input and output functionalities. Okay. And now we have to write functionalities also for the create, read, update, and delete. Okay, so let me give another comment. So CRUD functionalities so define add to do as PyCharm is suggesting, and then we'll take in the to do name also. And then here, okay, here we can say, you know how we add a new item to the dictionary. I'm not performing any checks because this is just for demonstration purposes. Other than that, I would have performed checks here to make sure that what is coming in is a string, it's not empty and all that. Maybe if you are implementing this same thing at your end, because you have more time than I do, you can do that check. First check that this is not empty. The user does not pass in just an empty string to find stuff. Find your code is able or may be able to catch it. You use try except blocks to catch it, but that is still a like it will be like a waste of the computer's resources and power. If it is just empty, stop it. No, don't go further to check for any keys and all that. Just return. So here I'll just say to-dos, which is our dictionary, and then I'll pass in the to-do name that is here. That should be equal to, so this place I'll take more than a name. I'll take the to-do name, I will take maybe the description also. And then I'll make the to-do description. So provide a name and a description for all of them. The format. Good. So this is all that the add to do does. That is all. And then, so that's the create. So the read, I think the read we did it here. The display all to dos. Okay. Yes, this is the read operation. So let me copy it or even cut it and then add it to this part of our code. And what again do we have to do? Now we have create, we have read. There should be update to do. Update. So define update to do. Let me pick this. I will only need, I don't, okay. Yes, I will need a description also in case the person wants to update the description. And then in here, I can say to-dos, to-do name, and I'll set that one to be equal to the to-do description. It looks like the creating of it, but that is how we also update stuff in dictionaries. Okay, I don't want to return to-dos. And then the delete to-do, define delete to-do, which I'll also take the to-do name. And then here, this is quite a new syntax that Python is suggesting. So let me pick it up. This delete is also another keyword. I think it should be coming from built. Okay, this is a keyword. It's not coming from built-ins.py. So we can use this thing to delete stuff. Yeah. Other than that, we could have just removed it also. But I think we can just accept this default. Okay, so the root operations is also now complete. What again do we have to do? I think we created a file. Okay. Okay, so I think that is it for now. So if we now want to test our system here, you see that I'm having different functionalities all in one file. And yes, for just a small project like this, just 39 lines of code, including spaces, it is not really a big deal. But if you have a project that is so many lines of code, you can go to like 100. If you check, if you are watching this on YouTube afterwards, or if you've been watching the live stream and you go and watch it on YouTube afterwards, you can just, after this video, go through the channel's videos and check the playlists for some of the stuff. Maybe I have a playlist for building a modern music player with a Python framework called PyQt5. If you check that one, especially towards the end, the last episode in the series, you see that probably around 600 lines of code just for one file. And there are many other files that I created for that project. So I modularized it. And even that, the main .py file, so to speak, contain about 600, 700 lines of code. So things can get very, very, very lengthy here. And if assuming this is like 700 or 1,000, 2,000 lines of code, if I want to find or update one of these functions, fine, there are shortcuts like Control F I can use to find any keyword inside my code, but so that I can go ahead and then edit it or delete it or do whatever implementation I want to do. But if you modularize your code, you actually tell whoever is having access to your code that you are a good developer. So we can test all these functionalities here. They will work. In fact, I've not shown you this trick yet, but I want to collapse everything so that I can get some space. Any intelligent editor has this. So wherever there's a code block like this define function here, when I click on it, it will consolidate it into this. So if I need it again, I click on this three dots, it will unblock it, so to speak, and then something like that. So once I click it, see that I'll be having some cool spaces all over here, so that the scrolling and everything will be smooth. So what we have to do now first is to add a to-do. So you know that the process is to take the to-do from the user and add it. So adding a to-do. And then here I can say user input. I think I'm out of variable names. Should be equal to input. And then, no, how did we structure the take to do function? Okay. So we don't have to even do, we have to just call the take to do from user, and that will get us the input. So to be stored in this user input variable, I just hope you are returning it. Yes, we are returning it. So after we get it that way, we can add the to do here. We have to modify this a bit. So I want to take the to-do title and the description from the user at the same time. So let me give a notice here to the user. So type the name of the to-do. I'll convert it to a string very soon. And the description separated by a comma. Okay, so the person should type the name of the to-do and the description and separate it by a comma. So when the to-do is returned, we can split it up and then get the first part and the second part. You know all these things already, because if we do that, it will return it as a list, and then we can use indexing to get whichever part we want. So I can say to-do name all these things that we are writing should have been actually part of our function. So let's just pass in to do here, because I don't want us to be writing functionalities inside there. These places should just be some basic things that we cannot put in the function. So here, the to do that is coming will be a list. So I can say, okay, I can even make it directly. So to do 0. This means that the first element inside the to-do list that will come. Remember, the to-do list that is coming in will be the name and the description separated by a comma. So for instance, if I'm saying that, okay, the to-do name is code and app, the description can be maybe code to do app in Python, something like that. So this is how it will be. So we can access the 0th element, so to speak, here, this first one. That is what I'm doing here by to do 0. And then we can access the first one, so to speak, which is actually the second here. So inside here, I'll make it to do's 1, so that will be for the description. So that shouldn't be confusing at all. So to do and then 1. Okay, this was just for demonstration. It is not needed. And so we'll do the trick for us. You don't have to manually do stuff here. So here we can say add to do, and then we pass in the user input. After that, we have to display all to do. So for to do and to do, print to do. So let's just display all to do's and then see how that one will go. Okay. So now let's test our code and see. And because I want to add more than one item, let me convert this one into a while loop. So I can say while true, and then I want to perform this. I need to keep. So if I type quit, then if user inputs, I type quit as the first element, then I want to quit. So it's not equal to kill. Let me just use kill for simplicity. Then I want to perform the start. That means I want to add it. Else break. Okay, so unless, as long as I don't type kill for the first input, it should perform the adding, and then at all times, whenever we add a new one, it should print the to do for us, so that it doesn't break on the first. Okay, so type the name of the to do. So code, that'll be the first one. Then here will be code to do app with Python. Okay, okay. Well, something is not really happening right. We have an error. I wish I can say it was intentional. It was not intentional. I forgot it. So just to also remind you that irrespective of whoever the person is, nobody writes software from scratch to completion when everything was perfect. No, we encounter bugs, runtime errors, and all that, and we fix them. So that is how it is. Where we are accepting the to do. Where we are accepting the to do. Where is it? Take to do from user. Okay. What happens is that if I should bring up the whole thing that I typed at the terminal, let me bring it up again, will come in as a string. This whole thing. I can bring that one up. Will come in as a full string like this. Python will not convert it to a list for us, even though that's how we want it. So what we can do is to split up this string on the comma. So the split is, that means if you see this particular character we were using for the split like break the string or whatever it is we are splitting into several components or subcomponents. Everywhere you see that particular break or split variable, like in this case the comma, break it. So this one, if you use the split to break it, it will break it into a list like this. Let me bring it up. The list will be code, and then the next one will be coded to do app with Python. So when we split it on the comma, we will get a list like this. Great. I don't know why. I just hope you still see it. Especially there's a comma here. If you don't see it, PyCharm is trying to tell me that my code has no effect and it will not leave the underline also. So in order to get something like this, in fact, if we first print to do before returning it, you understand what I'm saying better. So print to do. Then let me run our code again. Code to do app with Python. You see, this is it. It's a full string. So if we just, what did I just do? Sorry about that. If we just say get the first element, it will get C, and the second element will be O. That is why it stored them in there like that for us. So we have to split it now. So if we split it, we can say to do underscore name, comma, to do underscore description. This is one way we can also create variables. If you want multiple variables on all on one line, it is possible. So there are things I don't mention, but as we go along, you see how I'm using those ones, so you can get used to that one also. As I can say to do 0, and then to do 1. That means that Python splits the to do and then get a description and the name and the description. But this still wouldn't work because it will print the C and the O if I just also type code. So because I know, I say to do now dot split. And what do I want to split it on? I said it's the comma. So now this will split the to do for us, and then it will return the list I showed you not long ago, so that whenever you want to access the first and second element, stop and rerun, it will come as a list rather. So code and app with Python. It is still not working. What is the problem here? Okay, so to do should be equal to do dot split. Sorry. Hoping that this will work. So code and then code and app, just to keep things short. And now you see here that I have code and then code and app. So we have been able to split the string into 2 based on the comma. That is great. And so we don't need this print statement here. It was just for the debugging purpose. And then the place where we get all to do's, I think we can here say that just to decorate our terminal a bit, I'll put a backslash and so that to go to the next line, and I'll just this one. What I'm doing here is just to start the terminal. These are all your to-dos. So that you will see something displayed there, something nice displayed there. Okay. So again, let's run our code. Code and app with Python. And so now you see that these are all your to-dos. And then you have that in here. I should have put in another line down there so that it will also space it out nicely. So this one will be play, go and play golf. It's my favorite game to be. If I must say, I like to play it. And so you see that now I have 2 to-dos in my dictionary, and it is all being listed down here. In fact, you know that continue to type other things here. It will also be added to our dictionary. Another description. It will also be added here like that. So now let me type quit. Okay. Because it was looking for a comma, the exception was raised. So I can easily catch this exception here. Okay, I will not do that. That is not the purpose of today's session. You know how to catch exceptions. So I'll not do that. So now let's see, how can we even update a to-do? So in that case, our while loop will now become a little complex. So we have to know whether we are adding or adding, updating, or deleting. Okay. But you can see here that the code is growing large and large, and I have to scroll up, down, and all the time. So if we are using modularization, how will such a thing work? Okay. So what I'll do is I'll open up the other files, so the crude functions file first, and I'll come and copy everything here. Let me actually cut it and then paste it inside this crude things here. It is complaining because it doesn't know to-dos. Okay, so what we have to do is this to-do, if we put another to-dos here, sorry about that. If you put another to-dos here at the top of the file, what will happen? You may think all of them are one, but what will happen is that this one is only specific to this file. This to-do also is only specific to this file. They are not one. I have a comment. Yes, the quick statements. Oh, okay. I get what you are saying. Okay, so let me bring everything back. And then if I try it again, and then maybe code something, then I type kill. It will still throw that exception because it cannot split kill by a comma. Yeah, so that is why it did that. If I rerun, and then now I say code and app, and then now I say kill, comma, anything else, just to tell you that anything else can follow the kill. Now it will fail honorably because it was able to split on the comma, and then the first one that came in the list was kill. Okay. But thank you for that submission. At least we also use it to learn another thing. Okay, so back to undo. Let me see if I have it here so I can delete these ones for the crude here. Okay, so I have up to update and delete here. Okay, so this one is only specific to this file. In fact, if I now here add in some things here, anything, so first one is code, the description is code and app, and I try to print to-dos. Let me comment out this one because it will give us trouble. But if I go ahead and print to-dos, you will see an empty dictionary. See, it's an empty dictionary. Even though inside the crude operations file, we have some data in there. So what I forgot that we have to do now is to create even a new Python module. Now I know that you know the Python module is a Python file where the dictionary will be stored. So I can say database, because that's a database. And then in there, I will paste this to do. So let me cut it also from here and then paste it in. So now how do I get this to do here to work? How do I get all my files to work with this to do? Well, that is the essence of the modularization so that we can link functionalities. So if I want to use these to-dos inside any file, all that I have to do is to import it. So add it. Let Python know that I want to add it. Where do I want to add this to do from? It's in a file called database. So I can say from database import to do. And let me raise something here. Okay. This thing here is the Python file name. If I control click on it, to take me to that particular file. And so if you name your file and let's say it's the name is the same with a package you have already imported or the standard Python packages or libraries like the OS, CSV, excuse me, there will be a problem because now Python will be confused. Are you importing, let's say this file name was CSV. So if I say from CSV import to do, it will not be confused. Are you importing the CSV file in your project, or you are importing the CSV that comes with Python? So if we want to prevent something like that, usually you want to put dot here. If we say dot database, you know from previous sessions that this dot means the current working directory. It looks like our syntax is wrong for this one, so I can say, is it to do's or to do? Wait. Okay, it's actually to do. Sorry, so it's correct. It's correct. It is trying. Is it PyCharm will just try to format it because it's using the intelligence behind the scenes to do that. But to be safe, just put a dot there, especially if the name of your file is the same as any of the core Python packages or libraries. So if you now say from database import to do's and we print to do's, we will not see an empty dictionary like we saw before. It says relative import with known parents. Okay, so this time around is Python telling us to remove the dot from there. It can handle it, so no problem. And so now you see that I have code and app. It is not declared in this Python file. It's in a complete file on its own, but I still have access to it. So that is the beauty of code modularization. So now we can work with these to-dos that is in another file like it was in the main file, because when the code runs, it will import it into it. Okay, so another way I could have imported is be like import to-dos from, database. This will also work. No. Okay, this syntax is really not working. I think this is for installed third-party library. So let's just maintain this syntax for now. Okay, so we know that we can actually uncomment this, and then we don't need this. But now also see that there's a red underline here. Python will tell us unresolved reference, add to do. It doesn't even know what this add to do is. And you know that if we want to use functionality from another file, we have to import it here. So it is inside the CRUD functionalities. Remember, the CRUD functionalities also use the to do. So we have to say from database import to do's. Okay, so that our code will not be angry at us. And so after that, we import it here. We can use it so that we want to, when we want to create the to do and all to work. I think I had more here than here, so it just doesn't make sense. And then I now remembered I have to do an empty print statement here so that it will print an empty line. So inside main, I can also now say from, what's the name? CRUD functions, import. I will import a lot of things. So I'll import the add to do. I will import, would we have, let me see so there is get to do. There is also display all to do's. There is also delete to do. And there is update to do. And then I'm not importing to do's. Okay. Okay, so you see that we can actually also import the to-dos from the other file that is importing it, but I will not do that. I will import it from the main file itself. Okay. This is like importing specific functionalities that I will need. There is also another type that is not recommended, but I have to show you so that in case you see any other code base that does that, you know it. If I say from, so import star, the star here means import everything that is from it, everything. But the reason why it is not recommended is that they can be name clashes. So let's say you are building a Python library that performs visualization. You can choose to name one of your functions show, the one that show the particular thing you want to visualize. And I'm also writing a Python library for graphing. And if I want to show my graph, the function that I use is show. If somebody somewhere installs our libraries and use them both, imports them both into their project, and then they now say from your library import star, and then from my library import star, and then they now say show, Python will be confused. Which of the shows are you calling? Is it from um, person A's library or from person B's library? So usually you want to import them like this. And then one of the way to also correct that, Python uses what we call import aliases. So I can say from so import add to do as add to do. So in that case, whenever I want to use the add to do function in this file, I would rather use added to do, and then Python will still know that I'm calling the add to do function. In fact, let me from database import to do's as our to do dictionary. Okay, so if I comment out these things here, I just want to show you the import aliases and how it works. You know, when I wanted to see all the to-dos, initially because I imported to-dos, I printed to-dos. But now if I even try it, Python will raise an error that there's an unresolved reference. But if I print out our to-do dictionary, it will not raise an error. It will print the details in there, just like we are printing to do. So import aliases also work. You can use that in case you want to prevent those conflicts. But now I will not be using it. We don't have any conflicts like that also. So I'll not import star because these are the functions are not many. But there are instances where I use import star. You can't really import everything, especially from large libraries. But in any case, you have to prevent doing that. If you can, then prevent yourself from doing that. So now you see that Python knows that there's add to do because we have imported it from the crudefunctions.py file. So we can run our code now, even with our functions in separate stuff, and it will still work. So let's go ahead and then now put this input output to in its file because it has a module there that we can use. And here you know that I have to import the to-dos because all of them are using it. So from databases, import to-dos. So that's, are we actually even using it here? No, we are not using it here. So we are not using it here. So we don't need it. We don't need that import here. Yes, this file, this one can be just as it is. So inside our main, we have to, you see that it's now also complaining that it doesn't know the to-do from user. So we can say from input, output functions, import, take to do from user. So this is all code, all that code modularization is about. So we have modularized our projects into separate models for now, and then we are linking all of them together to achieve the same function. How do we know that we have achieved the same function? And that will happen if we run our code and see. So here, I'll run it again. If everything works, then we should see the things being printed like always. Remember, we already have one item in our database. Like more technically, you see we have seeded our database. So we added existing data for testing. That is seeding. And so I can say play, comma, go and play golf. And now you see that it is working as perfectly as we had all the functionalities in the main.py file. So I can go ahead and add so many things I want to do. Maybe, how should we do again? learn, and then what we want to learn now is maybe web development with Python, maybe web development with Python. And then it will be displayed here. These functions are all being called from different models and everything is working perfectly. All of them syncing perfectly with our to-dos here and all that. So that is it all about code modularization. I can go ahead and give it 1,000 things. It will still display them for us. And I know you know that. So our main.py file reduces to just this number of lines of code from 30, was it about 33 or 38, thereabouts, to just 15 lines of code. Yes, of course, including spaces. And so, given the time that we have left, I don't think I'll really be able to implement the get to do, delete to do, and update to do. And if I'm to do that one also, then maybe we will not be able to do the third-party libraries today. Maybe that will be tomorrow. So that's okay. We can even get enough time for that. I will not rush through things. So permit me to do that one tomorrow. And so for now, let me implement the get to do and delete updates all in this while loop, so that those of you want actually to maybe to get a full. I don't think we even need this here. This one was for just demonstration, so you don't need it. So those of you who want to just get a full working application will do that. I must say that I did not prepare this one in advance, so I'll be encountering bugs like you've seen me. I've encountered a few bugs that are fixed. So if it doesn't go very smooth as you expected, just know that that is how things usually are. Nobody builds software from scratch, and then everything was perfect from start to end. Yeah, you be doing testing, getting bugs, and fixing them. So what is it now that we have to do? First thing is that you have to even ask the user, what do you want to do? Add, delete, update, or let me bring these ones to different lines so that I can see them all together. When I hit, I just put the cursor somewhere and I hit the return or enter key, and Python intelligently added this round bracket for me. So that will not cause any problem. So the first thing is to ask is maybe input what do you want to do? And then in a \n, A is for add. Let me space them out that to be nice. Add to do. And then let me see the suggestion that it is bringing up. B is delete to do. And then C is what? Update to do. And then I think we have 4 functionalities. Will you be able to guess the last one? I don't think it did. So I think that's all. Yeah, that's all the operations we actually need. So in order to make it nice, let me separate these ones onto different lines. Okay, so after we ask this input from the user, now we will perform an action based on the user's input. So if ask is equal to A, oh yeah, that is it. So in the case where the user types a capital A, let's still catch that exception. So we can say ask.lower is a string method. What to do is that even if you type an uppercase, it will convert it to a lowercase. So if I type uppercase A, it will still convert it to a lowercase a, so that this matching or this comparison will make sense. So if ask is A, then that is where we want to do this. And then, okay, we have to take the user input first. And that is it. So if ask is A, then we want to do that. Okay. Oh, what is wrong here? I leave ask dot lower is B, we want to delete a to-do. So we'll still take a user input from the user. But this one, no, we cannot use this method because this method will split whatever we give it. Remember, it will split it. So we cannot use it. We have to use the ordinary import here. So input, and then type the name of the to-do you want. Is be deleting. Okay, you want to delete. And then after the name comes, I can say delete to do and then user input, because you know that the delete to do takes a parameter here, which is a to do name used for the deletion. So that's what we pass in here. And so we can go ahead and say, I just want you to see everything in one line. So, yeah. So don't just be confused. I just want you to see the whole code. Other than that, I could have kept it in the whole sentence. I know some of you are following up and typing so that if your speed is not like mine, which is also quite slow, you can still see what I'm typing. We can go elif, not in this block. So elif, ask.lower, we are not even having a D in there. C, then now we want to update the to-do. So permit me to just copy this thing here to speed up the process. We will still take the user input, and then here, so to do, we want to update, and then we can say update to do and then user input. So this is what will happen. So the else break now works, because if you type any other thing apart from, okay, there's a problem here. The update to do takes more than one input, so should be the to do name and description. So the update to do's functionality will even look more like the add to do. So where is the add to do? So we have to use this user input rather, and then pass it in rather, so that it will split it. So I don't think we have to. Okay, this one still works. There's something we didn't factor when we were creating the update to do. Yes. Okay, so we can modify this thing to do that, but permit me to copy this and then paste it. But I have to change this name here. Take up maybe update to do. Maybe update to do from user input or something like that. Because the functionalities will be a bit different. So that we can still have this our message display. So type the name of the to do. Type the new name of the to do and the new description separated by commas. And then now what would you like to update? Okay, I don't think this line is even necessary. Is it? No, it is not. So we can copy this, replace it here, and delete this one. Other than that, to be just redundant information being displayed on the terminal. I just hope no one is confused by this thing that I'm doing. So inside main, we have to also import that from the input output functions. Okay, so that we can use it in the update function rather. So here will be user input equal to update to do from user input. And then here we still should give it two things. So you can say user input 0 for the first part that will be returned from the user input, and then user input 1, because you know that this will return two things, the first and second. So we can just pass it in straightforward like that. Okay, so now this one too will do else break. So let me go over the code again, this whole thing here again, in case it confuses you. I know you understand the modularization and the separation of the functionalities into different modules and files. So now we ask the user what the user wants to do. If the user types A, that means they want to add a new to do. We add it, we display all to dos. If it is B, they want to delete, we add it, and we also should display all to dos, so that we know that the deletion worked. And then if it is C, we have to update it and then display all to dos again, so that we know that it worked. Maybe you can print something here. Program is quitting. See you back soon. Maybe see you soon. I think this is a bit rhetorical. Let me add my emoji here of my favorite. Yes, you can put in emojis too inside strings. I showed you the other day that this one has an Unicode value. We actually printed it. So you saw it. So now this is our complete to do app. And so now it asks me, what do I want to do? And so I don't think this everything will work, but I don't think we did the right thing as far as usability is concerned. So I can say here another \n to format it and now say your choice, so that the user will present a choice between all of these. Okay. So now I see here your choice, so I know that I'm typing my choice. I put uppercase A, the string dot lower will convert it to a lowercase, and I'll still be able to add my to do. So A, and then now it says type the name of the to do you want to add, separated by a comma. And then I'll say play again, and then play 12. So that it worked. And then it says these are all my to dos. You see that it has now been updated here. And now let me add one more, which is, so I'll come back again and put a choice. I know it's A. I'm being prompted again, and I now can say learn again, and then learn data science with Python. That I know that has also been added to our database here like that. Now, what do I want to do? I want to update it to do. So I go C, and then now you see that it says type the new name of the to do. So I didn't style out that one well, but just bear with me. So I want to update the learn. So I will type learn. And the comma is learn data science with R. This is also another programming language. And so now if the update works, when our to-dos display, we should see that not a new to-do, but this same to-do, but to not rather be Python, to be R. So let me just hit enter to make my submission. And you see that we still have 3 like we used to have before, but the update has occurred. That is great. And so we know that the update is also working. Now I'll choose B and then delete a to-do. So let me delete the code, the one we used to seed. And then now you see that when the output came, it has deleted the first one, so there's no more code and app here. It's the play golf and the learn that is there. So now I'm done with I'm done using my to-do. So what I can do now is to type create. In fact, now everything that you type here, you type anything, because we said else. So anything at all that we type that is not A, B, or C, we'll let our program quit. So I can actually type anything at all. And then we see that program is quitting. See you soon. So that is it about code modularization. I just hope that this to-do app example helped you to really understand it well. If you have any concerns, you know that you have to drop it on the page, and now myself or the whole team, anybody can come up and then help. And if you think that you have to send it to me personally too, that is fine. If you're watching this after stream on YouTube, you can drop your concerns in the comments and I will come back and address it for you. If you think you have to also see, message me personally. If you go to the about section, you see the email there to WhatsApp me, so you can do that one too through the mail. And so that will be all for today's session on modularizing our code base. So if there is any questions I have to address on air, as usual, I will allow 1 minute to do that. Other than that, we'll call it a day and anticipate for tomorrow. I think maybe, I don't know whether any of you be interested in this code here. Maybe you really like it, like today you have really built a functional app or something like that from scratch. If that is the case, you can let me know so that I upload it to the Google Classroom so that you can download it and have access to all these files also. I think that will be great. Get to do, we never used it. Okay, because we are printing all our to-dos also, so no, that is not a problem. Okay, there are no questions, so that will be all for today. I will zip this file, as I said, all the files, and I'll also upload it to the Google Classroom for you to access. And so thank you very much for your time today. As always, I encourage you to keep on creating. I want you to be showing me some crazy stuff you have been doing with Python ever since you started this bootcamp. And then until tomorrow, that will be goodbye from my side.